Yeah, thank you very much for visiting our YouTube channel today. Today we'll be looking at this triangle. This is a typical set question, and we have been asked to solve for this line NQ. Line NQ. We want to look at the length. We want to solve for this line NQ. So, first in mathematics, analyze the triangle first. Our first step is to analyze. Step one is the analysis of this triangle. Analysis of the triangle. Number one, we know that from this triangle, from triangle NMF, we know that it is a right angled triangle. That's a fact. And that fact is that the legs of the triangle NMF, this triangle NMF has lengths. That is, the legs have 3 and 4. 3 and 4 units. That is, NN is 3 units, YNF is 4 units. This NN and this is NF. So this is the corresponding length. And we also know that this Q is the foot of the altitude. Q represents is a foot of the altitude N. Is the foot of the altitude drawn from the vertex to the hypotenuse NF. The foot of the this Q is a foot of the altitude drawn from the vertex N to the hypotenuse MF. This is our hypotenuse. So that draw from the vertex N to the hypotenuse MF. And our NQ will represent the altitude to the hypotenuse. Our NQ represents, that is this, our NQ represents the altitude to the hypotenuse MF. So those are the facts that we can derive from this triangle if we want to have a good solution. So the approach we're going to use now is the area formula. This. And we know that the area of a triangle is half distance height. So we're going to use, our first leg is 3 units, which is 3, and our second leg is what? 4 units. So simplifying this further, we are going to have what we call 12 over 2 will give us 6 units. So our area now is 6 units. The same area can also be expressed. This same area can also be expressed using the hypotenuse as a base. The same area can also be expressed. So be expressed using the hypotenuse as a base. So in that, we get this: the area is equals to 1/2 times hypotenuse times altitude.